Okay, welcome back to another video on my channel. It's your teacher, Ms. Lim here. In this video, we're going to be looking at complementary events. So I've got the relevant syllabus dot points here. I'm not going to read it out, but if you want to have a look at it, please just pause the video. Okay, so let's have a look at the first part of this lesson, which is what are complementary events. So complementary events are basically just two events that are the opposite to each other. Okay, so for example, flipping heads is a complement of flipping tails. Okay, now we just write the word not in front of the event to identify the complement. So for example, we know that the complement of rolling 3 could be rolling a 1, 2, 4, 5, or 6, but rather than saying that, we can just say that the complement is not rolling a 3. Okay, so not rolling a 3. And that makes it nice and easy. If we just write the word not in front of it, that takes care of all the other possible outcomes. So for example, if we have a look at question B, selecting a blue marble, the complement to that would be not selecting a blue marble. The reason why that's a complement is because often students say that the complement of selecting a blue marble is a red marble, or a green marble, or yellow marble. But what about all the other colors? Okay, so we actually need to just say not. Put the word not in front of it, not selecting a blue marble. Okay, picking a weekday. Now you could say picking a weekend, but let's just get used to just doing one thing and just writing the word not. So I'm going to write here, not picking a weekday. And driving a red car, not driving a red car. Okay, that word not is very helpful when it comes to colors. Okay, because people might say, oh, driving a white car, okay, or blue, or black. So not driving a red car is everything else. Now the complement of an event E is denoted by E bar. Okay, so we've got this little bar at the top, but I'm just going to call it not E rather than E bar. So I'm going to say this is not E. So let's have a look at finding the probability of complementary events. Find the probability of rolling a 3. Well, on a fair die, we know that there's only 1 3 out of the 6 different outcomes we could get. So the probability of rolling a 3 is 1/6. The probability of not rolling a 3 will be 5 out of 6. Okay, that's 1, 2, 4, 5, and 6. That's 5 different outcomes out of the 6. What do the probabilities of the complementary events add to? Well, the probability of the event plus the probability of not the event, we can see is 1/6 plus 5/6, which is 6 out of 6, or 1. Okay, they add to 1. Let's have a look at another example. Okay, so here there are 9 blue, 3 red, 2 yellow, and 5 black marbles in a bag. What's the probability that it's blue? Well, the probability that it's blue is 9 out of how many marbles are there? 9, 12, 13, 14. There are 19 marbles in the bag. Okay, so there's 9 out of 19 chance that it'll be blue. What's the probability that's not blue? Well, there must be 10 out of 19. 10 out of 19 are not blue. Okay, we can see 3 red, 2 yellow, 5 black. That's 5 marbles that aren't blue. What do the probabilities of the complementary events add to? So we can see here that blue and not blue are complementary. They're the exact opposite of each other. So the probability of blue plus the probability of not blue is equal to 9 out of 19 plus 10 out of 19, which is 19 out of 19, or 1. So there are pretty much two main formulas that we will get out of this, okay? The first is the sum of the two complementary events will add to 1. Okay, so that's one of them. Or the complementary event is equal to 1 minus the event. Okay, it's up to you which one you want to use. They're both technically the same thing. All right? So we've got E is the event or outcome, not E is the complement of the event. So let's have a look at some examples. Lisa selects a card at random from a normal pack of cards. Find the probability of the following events. Not a 10. Well, we know that there are 4 10s in a deck of cards, right? 4 of hearts, diamonds, spades, and clubs. Out of 52. So, because we want not a 10, and there are 4 10s, we need to know what 52 minus 4 is. It's 48. Okay, there are 48 cards that are not a 10. What we could do here is we could say that the probability of not a 10 is equal to 1 minus the probability that it is a 10. Well, because we know that there are 4 10s out of 52, we can just put that in our calculator and we can just say, 1 minus 4 out of 52 is equal to 12 on 13. And that's a probability that if we were to pick a card at random from a normal deck of cards, that it won't be a 10. Okay, we've got 12 out of 13 chance that it won't be a 10. What about not a black card? Well, the probability that it's not black is actually 1 minus the probability that it is black. Well, we know that half of the deck is black, so I'm going to do 1 minus half, which we won't need to use our calculator for this. We know that's equal to half. Okay, half of the deck is red. What about not a picture card? So you really need to know your deck of cards, okay? So a picture card is pretty much Jack, Queen, or King. Okay, and there are 4 of each, so there are 12 picture cards in total. So the probability that it's not a picture, okay, not a picture, I might write pick. Alright, so not a picture is actually 1 minus the probability that it is a picture. Well, we know that there are 12 picture cards in total out of 52. Okay, 4 jacks, 4 queens, and 4 kings. So now we can just put that in our calculator. 1 minus 12 over 52, which is 10 on 13. Okay, so if we were to pick a card at random from a normal deck of cards, there's 10 out of 13 chance that it won't be a jack, queen, or king. Alright, let's have a look at question B. Find the value of the complement given the following information about E. Okay, so if the probability of an event is 1/5, then the probability of the complement, what is that equal to? Okay, 1 minus 1/5 is 4/5. Alright, why don't you pause the video and have a go with the rest of these. Alright, question B. So the probability of an event is 0.9. So what's the probability of its complement? The probability of its complement is 1 minus 0.9, which is 0.1. Question C. The probability of an event is 62%. So the probability of its complement is 38%. 38%. Okay, 1 minus 62%. You can just do it like this. 1 minus 62% is 0.38 or 38%. So if you wanted to, you could have left your answer 0.38. You could have written it as 38%, or you could have written it as a fraction 19 over 50. Okay, up to you. Now for question D, we've got the probability of an event is 1 to 4. So when you've got a ratio, it's probably best for us to think of it as a fraction. See that column there? Pretend it says 1 divided by 4. 1 divided by 4 is technically 1 over 4. right? So that's the probability of the event. So the complement, the probability of the complement is actually 3 on 4. Now, I might not write 3 on 4 here because this is in a ratio, so I might keep it in a ratio as 3 to 4. Okay, so that's how I would write that. Question E. The probability of an event is 3 on 11, so the probability of its complement is 8 over 11. Okay, 1 minus 3 on 11. Question F, the probability of an event is 0.45, so the probability of its complement is 0.55. For question G, probability of an event is 37.5%, so its complement will be 62.5%. And for question H, we've got 3 to 7, so the probability of the complement will be 4 to 7. 4 to 7. Alright, let's have a look at the very last question of this lesson. A 12-sided die has faces marked 1 to 12, but the die is biased. Okay, so that doesn't mean that all of the faces have the same number, will have each number occur once only. Okay, here it says the probability of rolling an 8 is actually 0.1. Of 2, it's 0.15, and the probability of not getting a 3. Okay, so just remember, this symbol means not. So not 3 is 0.91. Find each of these from A to H. Pause the video and have a go with this one yourself. Okay, so the probability of not 8. We know probability of 8 is 0.1, so not 8 will be 1 minus 0.1, which is 0.9. Question B, probability not 2. We know the probability of 2 is 0.15, so not 2 is 1 minus 0.15, which should be 0.85. Okay. Well, we can see here the probability not 3 is 0.91, so the probability of 3, the complement, will be 1 minus 0.91, which is 0.09. Alright, question D, E, and F should all be nice and easy because we're adding 2 complementary events. So probability of 8 plus not 8 is just 1. 2 and not 2 is also 1. 3 and not 3 is also 1. So that should be nice and easy. Question G, the probability of 2 and the probability of 8. Well, here the probability of 2 is 0.15. The probability of 8 is 0.1. So we've got 0.15 plus 0.1, which is 0.25. And here we've got the probability of not 2 or 8. Okay. Now you might be tempted to do this, right? You might be tempted to say, oh, it's 0.85 plus 0.9. Let's just say you did that. Okay, you said it was 0.85 plus 0.9. And you did that because not 2 is 0.85 and you said not 8 is 0.9. The problem with that is when we add them together, that's going to give us 1.75, which is bigger than 1, right? It's not possible for us to have a probability greater than 1. So that's actually not the right thing to do. What we need to realize is that this is actually the complement of G. Okay, probability of 2 and probability of 8 is 0.25. So not 2 or 8 is actually 1 minus the 0.25. So this is actually equal to, I'll just write it in black, 1 minus the probability of 2 plus the probability of 8. Okay, so we need to do 1 minus whatever this is. Well, we worked out in G already that this is equal to 0.25. So the answer is 0.75. All right. .75. Don't know why my thing is laggy, but that should say 5. All right, so what did we learn in today's lesson? Okay, today we looked at complementary events. We said complementary events are two events that are the opposite of each other. So the quick and easy way of identifying the complement is to just write the word not in front of the event. We use this notation, the bar at the top, to identify that it's the complement. And we use the fact that the probability of an event plus the probability of its complement will always add to 1. Or the one that I used throughout of this lesson, I use this one. The complement is equal to 1 minus the probability of the event. Okay, the probability of the complement is equal to 1 minus the probability of the event. Okay, and we can see that throughout here. 1 minus, 1 minus, 1 minus. Okay, so that's it for this video. If you still have any questions, please comment down below. If you found this video helpful, please give it a like, and if you would like more content, please subscribe to my channel, and I'll see you in the next video. See ya.